Okay, so we're going to be looking at titrations, and first thing really to get our head around is all this equipment. You see that I've set up a clamp stand with a white tile, and the reason we've got a white tile is that because the acids and bases don't have any colours, to see what we call the equivalence point when they're fully reacted, we need to use a coloured indicator. So the white tile helps us see the colour change of the indicator a lot more easily, and that's why we put that down as well. This piece of equipment is called a burette. Alright, it's got numbers going up here, and of course if we let the volume get below that bottom value, this becomes useless. Okay, so what we're doing here is we're using simple maths, subtraction, to see the difference in the starting volume and the finishing volume to see how much I actually use for the experiment. These are accurate to 0.05 of a mil, so they're pretty darn accurate. So that allows us to be good to 3 significant figures if our, what we call titer, our volume used, is more than 10 mils. At less than 10 mils, we're only good to 2 significant figures. This funky looking thing here is called a pipette or a pipette, depending on how you like to say it. I like to say pipette, I don't know why. Basically, these are one of your most fragile pieces of equipment, so try to sit them somewhere next to something that will stop it rolling off the bench. Okay, so I like to put it next to my bottles of things. So if it rolls, it just hits them and stops. These have a value written on them, in this case 20 millilitres, and that volume is precise again to, depending on the thing, in this case 0.03 mils. So again it means it's 20.0 mils if I fill it to exactly the line. There's a wee etched line in there if I fill it just to that. Filling them is quite tricky. So we use a thing called a pipette filler. It may come in different shapes and sizes, but that's what this is. Basically, what we do is we attach this on here, hands close together, not out like this. Those physicists in the room know that doing this, any bending will create a huge amount of torque. That torque translates to force in the area where these two things meet. Smash, slip, cut. Okay? Don't want that. We'd like you to stay unbleeding. So we're going to do it nice and close together, a little bit of pressure and a twist, and we're good. It doesn't have to be all the way in down to there. Okay, it's just on. Then what we can do is we can roll the little circle thing here up, create suction and pulls things up. I'll show you how to fill that and fill those in a moment. There's a couple of techniques. One that's a lot more reliable than the other, but both work. We always have to have some distilled water for this, and that's for rinsing our gear out. Not all of the gear gets rinsed with distilled water, just be aware. We are going to use little conical flasks to have under our burette, because they're easy to swirl without spilling anything because of their narrow opening. That's one of the main reasons these things exist, is for this sort of experiment. Anything you have to mix but not spill, and that's what this is. Alright? That's basically our equipment. The chemicals we need are a standard solution. We've got a sodium carbonate standard solution that we made yesterday, and we've got an unknown hydrochloric acid solution. Because we don't know how concentrated it is, we'll assume it's very concentrated. So treat it as if it's dangerous. You'll see I put it in a beaker. I rinse that beaker with the hydrochloric acid first, so that any droplets of water in there didn't actually dilute the acid. Alright? And case in point, I've just got some acid on my hand, so I'm going to wash it off with water, because I don't know its concentration. Okay, so how do we set this whole thing up? Well, what we're really looking at is we must keep the concentration of whatever goes in our burette exactly the same. Which means what we do is we rinse it out with whatever's going to go in there. We've also got a funnel, which we're going to put on top of that. So again, we don't want this to contaminate what's going in, so that needs to be rinsed with whatever's going in there. So what I'm going to do is I'm going to go with my standard solution in here. I'm going to put my funnel on the top. I'm going to close the tap, which is when it's at right angles to the rest of the burette. And I'm going to pour a little bit, not much, only an estimated 2 or 3, maybe 5 mils in here. I like to lift, I'm not sure if the screen can see that, lift the funnel a little bit so I don't get a suction, so there's a bit of air able to get in, and pour that in. And normally I'd have this over a sink, but because that won't be in the screen and being a bit risky and having it hovering over me. The reason for that is the tap could have a leak in it and it could still allow stuff out the bottom, so normally you do it over a sink. the other nice things. I know this is washing soda, so it's not going to do a lot of damage. That's about it. I'm only putting a little bit in there. Okay. Then what I'm going to do is I'm going to just run it up the burette again, turning the burette so that it's rinsing the walls of the burette. I don't want to waste a lot because this is my standard solution. I don't want to lose it. Okay, and so I'm up to the 0 mark, so I can now fill the whole thing. Now I'm going to turn it back up, go over the sink, and let this out, but not all the way. I'll show you what I do. You'll see the air bubbles. I'm trying to get rid of those. Although this stuff in the bottom isn't exactly, perfectly clean because it's been used to rinse this, I still want a little bit in the bottom because my first titration that I do is going to be invalid anyway. That's my guess one, you'll see in a moment. So what I'm doing at the moment is I'm just trying to get rid of an air bubble, which is still there, but that's okay. I'm going to clamp this on. Now you'll notice I'm clamping it quite low on the burette. This is so I can read all of the numbers. If I clamp over one of the numbers, Murphy's Law, which isn't just true scientific law, but Murphy's Law states that my result is going to be exactly where that clamp is. So I'm going to clamp it at the bottom where there's no numbers, so I know that Murphy can't come into play. Alright. So now I'm going to fill it up. And again, one of the things that I do is I elevate the funnel just a little bit with my fingertip and pour very slowly. I look up, I don't look down, because I don't really want the standard solution all over my fingers. And for today it's probably enough in there. I don't need to go to the very top. I just go as far as I want. Then what I want to do is I can grab any vessel, be it a conical flask, whatever, and I'm just going to run this out until I get rid of these air bubbles that we can see. And I'm not sure if the screen will show it, but there's actually quite a big air bubble sitting around the tap. And hope that I can knock it out. And if it doesn't do it the first time, even in an assessment, stop, tell the technician or me, and we'll get rid of it for you. Alright, because there's a bit of a brutal way to do it, but you've just seen. Alright, now the air bubbles are gone, I can fill it up a bit more. And then the burette is ready. So, just to recap, I've rinsed the burette with the solution that goes in it. Then I've filled it up a little bit, got rid of the air bubble, and now I'm going to fill it up properly. The reason I do this is that I need to keep the concentration of this exactly known. Right, so that's been set up, ready to use. Lid back on my standard solution. So if it's warm enough, water evaporates, its concentration changes. And the concentration of this is really important. Okay, now I've done that, I've got to rinse this out before I use it, because otherwise it'll affect my result. So for that, I'd use distilled water. This is why we have the distilled water. So I just notice it's on quite an angle, so let's fix that. So here I'm washing the walls of it, giving it a swirl, again running it like that, and I'm going to do that twirling thing as I pour it out. I'm going to do this twice because I basically know that I've put the standard solution in this one. But if you know that it's already clean, which all the ones that you're using are, then just do it once just as a precaution. All right. Okay, next is my pipette. I'm going to put a certain volume of this unknown acid into here. I can't let its concentration change in the pipette, but it doesn't matter if it does here. You'll see why. It's the amount of acid, not concentration, that matters. The amount, number of moles. So, that means that this is not allowed to affect the concentration of what's going in. So again, this has to be rinsed out. Now, a lot of people rinse out with distilled water first. I actually think it's a step you don't really need to do. Unless you know that there's something stuck in the bottom you want to dissolve out, it's easier and better just to use the solution, just like the burette, use the solution you're about to clean this out. So we're going to attach our pipette filler. Again, we're not going to draw a lot up, and then we're going to take it out. Then over the sink, I'm going to put my thumb over the top to create a suction, and then take that thumb off and run that unknown solution into the bulb, and then quite a bit further. We have to go all the way to this little etched line here. Then again, still spinning it. Now, but back when I was at school, which will tell everyone who's watching this how old I am, we actually could get away with mouth pipetting, sucking certain solutions up. Now, hydrochloric acid was not one of those we were allowed to, thank goodness, but there were a few we were allowed to. Now it's a big no-no simply because more than one person uses each pipette, and we don't trust you to clean it properly and all that sort of stuff. But also it's not so nice to get certain chemicals up into your mouth. So what we're going to do is always use the pipette filler. And this is the trickiest, most time-consuming part of the titration. Get good at this skill, even practice pipetting water today, and you'll be quick at doing these. All I'm going to do is just draw it up by rolling that there, keeping an eye on the solution, not this. And I'm going to go too far on purpose, because when I lift it out, it'll drop a bit. Okay? Then, there's two ways to do it. I can slowly release it bit by bit, which I find really hard to do, or, and I always go way too far, I can use my thumb. And I'm right-handed, so I put my right thumb to do it, and I just went too fast. There's just seeing the issues with this one. If you haven't put it back on, lift it off the glass, please. We don't want the glass touching. That wasn't quick enough there. So I've created a suction there with my thumb, and it's holding the solution. Make sure it's not sitting in there. Make sure it's up. What I'm going to do is just literally roll my thumb a little bit, which releases the suction just a tad. I haven't had enough coffee today, so I'm shaking like a leaf. There we are. And when I get the bottom of the meniscus on that line, I stop and I put it into one of my conical flasks. And my habit with doing this is while that's going in, I put a couple of drops of indicator in, and only 2 or 3. I put the indicator in once I've put the solution in, then I know this one's ready for the titration. I repeat this step. Oh, sorry, there's one more thing. I touch the glass like that. There should still be a little bit in the bottom, but not heaps. Alright? Put the pipette somewhere safe so it won't roll off the desk. Now there's drops up here that are the stuff we want. So I'm going to use distilled water just to quickly wash the walls. Just a splash into here. Now I repeat this 2 more times, so I've got 3 ready to roll. I'm not going to do the 3 in a row now, just for time. So I would have 3 set up. For the first titration that we do, we go pretty quickly. We expect to overshoot. Alright, it's just a rough titration to get us what we call a ballpark figure. So what I'm going to do here is I'm going to, on a bit of paper, record that it is at 10.1 mils. Alright, I have this disadvantage of being too short to see it easily, so I go on tiptoes. You will not be laughed at too much if you use a chair to see it. I have to. Hey, I'm doing the laughing, and I should be laughed at for it too. So it's at, sorry, not 10.1, it's at 9.9 because the numbers start at 0 at the top. So 9.9 mils, so I jot that down somewhere. Okay? I'm trying to find the value. So, then what I do is, I'm right-handed, so I want to be swirling with my right hand. I'm going to control the tap with my left hand. Notice I'm going around to the tap. It gives me more control. And I'm going to just turn the tap on, and I'm not going to look up here. I don't care what the volume is. I'm going to look down here. I'm looking for a colour change. At the moment, it's red or pink. When it's alkaline, it'll go to yellow. So my end point is actually in between the two. What's yellow and red make? I just said I'm wearing the wrong colour for it. Orange, okay? I'm wearing a silly colour for this because it could reflect and it could give me a wrong end. If I go all the way to yellow, I know I've overshot. If I go to orange, I know I've got it spot on. So I'm looking for that first, what we call permanent colour change. I'm just going to look down here, keep it swirling, and ready to turn this tap off immediately. Okay, so a little bit of pink in there, so I haven't quite got there. Okay, we can see that it's changed colour, it's gone yellow. I've definitely overshot, definitely. The first titration is just a rough one that you won't use in any calculations. So I checked there and it's 32.7. So 32.7 minus 9.9 is 22.6 mil, okay? Now, if I had another one set up, what it means I know that I need no more than 22.6 mils because I overshot. So what I'd do is set myself up again. There's not quite enough left for that, in my opinion. There's roughly 20 mils left. Whoops. Now, I didn't do that on purpose, so it's quite good that it happened. You might see that some spill from the outside of the burette. If that ever happens, make sure you get a cloth and clean it. Cloth or a paper towel. So you don't want those drops coming down the outside of the burette and affecting the result. So you can give that a very quick clean. As I say, it's convenient that it happened, but it was not intentional, I promise. Okay, so I'm just going to very quickly set up another conical flask. Let's see how fast we should be able to do it. Oh, that is, oh no. Okay. Don't do any more than 5 drops of the indicator. Indicators themselves are weak acids, so, or weak acids and weak bases, depending on what colour they are, which means they can do a thing called buffering. So if you add lots, you'll end up seeing colour much more easily, but getting the wrong end result, because it actually can mess it up. Okay, my initial volume there is too hard to read, so I'm going to use it still. 1.0 exactly, so it's nice and easy. Okay, so now I'm going to go a little bit more carefully. I know it's going to be around about 22.6 mils, but I also know I overshot. So I'm going to run 21 mils into this, just with mixing. I'm not going to think about it. So 1 plus 21 is 22. So when I hit the 22 mark here, I'm then going to slow down because I want the rest of these to be very precise. So literally I'm just going to swirl this and keep my eye on the 22 mark. As you can see, it's really, really exciting. Fun for that. So, one other thing I'm doing now, because I want precision to be high, is I'm going to, if there's any droplets on the walls, I'm going to wash them with distilled water from now on. Okay? Because I don't know what those droplets are, so I will assume that they are a reagent. Okay, 22-ish, so I've stopped. So, as soon as we drop there, I'm actually going to let that go in as well. And I'm going to wash that wall with just a splash of distilled water again. Okay? Now I'm going to go really slowly. You can turn these taps so they go drip by drip or a little stream of drips. So I'm sorry that it's hard to see on the video. I'm going to try and get a stream of drips. As soon as I think it's orange, I'm going to stop. And my watch is causing a real problem because of reflection, but actually, I think I've got it. Okay, that's not pink anymore, is it? Alright, it's gone peach. Just close enough. Now, if I'm not sure, one drop won't make a difference. If I'm not sure, I'm going, oh no, is that pink or not? It's not. But if I wasn't sure, I'd go one more drop just to be certain. So we go really carefully. One more drop. And look, that, to me, it's the same colour as it was before, but it's not pink. So now I'm going to look at this. It says 22.8. So my new value is 21.8. That's considerably different to my first one. But I knew that I overshot the first one. So now, when I do my next one, I'm going to run in 21.5 mils and then go drop by drop after that until I get a more precise value. What I'm trying to get is, these are called titers. The values that we get from here are called titers, hence the word titration. Once I've got three titers that agree, which means they're within 0.1 mil of each other, so 21.8, 21.7, 21.7 would be great. I take those three values and I average them and we do the calculations. Alright? That's what we call concordant. It's when three values agree. If my next one though is 21.5, it's so far away that I have to keep going until I've got three that agree. Not three in a row that agree, but three that agree. So if I got 21.8, 21.5, 21.7 and 21.7, I'd ignore the 21.5 as being an outlier, an anomaly. Something went wrong. Okay? If however I got 21.5, sorry, 21.8, 21.5, 21.6 and 21.7, I'd have to probably do another one to check which end was correct. The 21.5 end or 21.8 end. Alright, and exclude the one that's too far away. Alright, but that's your titration. The hardest things are pipetting. That is hard. And the other hard thing is remembering what to rinse everything with. Conical flask is water. Pipette with whatever you're going to put in it. Burette with whatever you're going to put in it. And of course the funnel with whatever's going to go in the burette, because that's part of that system. Okay? Those are the key things to remember. Please remember to put lids on things again when you're not using them, because that stops any evaporation coming into play. Not so important with what you're using today, but it can be. But that's basically how to do a titration. Alright, we can do the calculations probably tomorrow. Thank you.